On number 44, we are to describe how to transform the graph of the natural log function graph into the given function. So the first thing we have to look for is the differences in the equations, and in this particular case, we only see two differences. One of them is the negative on the inside, and the other is the -2 outside. Remember, a -2 outside, like with all other functions we've studied, will move the graph down 2, and the negative x on the inside reflects the graph horizontally. So let's start by putting the parent graph on our plane, and because we don't know the logarithmic graphs as well, it's better to have the parent function to refer to and work from. So we'll start with the fact that since this is the natural log, its base is e, so it is the inverse of e to the x, which goes through the point 0, 1. So this graph, like all of these parent graphs, will go through the point 1, 0. And the second point that we can think about on the e to the x graph is 1e. So we're going to go to the right e and up 1. So we're going to go a little, not quite to the 3, and then up 1 to plot our second point. And trace the curve out from there and down the vertical asymptote. So there's the parent. So now we'll graph our given function by moving it down 2, and if we move these points down 2, the x-intercept would be there, and the second point would be about here. And now we're going to take these and reflect them across the y-axis to reflect horizontally, and the moved down intercept would be here, and the other point would be here. So we then trace the curve down to the vertical asymptote and make it go up and out forever to the left, and that's that graph. Then on number 52, same set of instructions but with a little more going on. We've got a -3 as our a, which flips vertically the graph, and a stretch by 3. The +1 outside moves the graph up 1, and then we have to be careful about the inside because the x has a minus and then there's another number in there too. So we're going to rewrite our function with the 1 factored out on the inside, which gives us -x minus 1, which helps us to see that that -1 that we just wrote, which was originally in disguise as a +1, is actually going to move the graph to the right. So we have a -1 in our newly factored form of the inside, so the graph is going to go to the right 1. So we know we've got to go up 1, right 1, and then flip vertically and stretch by 3. But let's not forget that the x was negative, so we're also going to have a horizontal flip. So now we'll see if we can put that on our graph. Again, we'll start with the parent graph, and we'll put that in orange to help it stand out. And then we'll come back to our green color to graph the function. So we know that it goes through the point 1, 0, which is there. And then because this is still, or no, this is the common log now, so our base is 10. So this is the inverse of 10 to the x, so the point 1 step to the right on the 10 to the x graph would be the point 1, 10. So we're going to go to the right 10 and up 1, which will put us right about there. And then trace that out. And it's going to be a lot flatter because the base is bigger. The bigger the base, the flatter the arc that occurs there. And then it would come down and hug the asymptote. So now let's go back to our green to graph this transformed function. let's deal with the reflection in the y-axis first. That's probably the easiest way to approach this. But if we reflect the first point, that's going to put us about here. And I'm going to circle these points instead of actually plotting them because of the fact that we still have to account for the up one and the right one, and then the vertical stretch and flip. So our first reflection would put our first point there, and then the second point would be 10 steps back to the left from our asymptote. 1, 2, 3. Which I'm going to run off the edge of the screen, but it would be somewhere out that way, and I'll kind of point the arrow just slightly off screen for that point. So now let's take the point that we just plotted and go up one and to the right one, which would put us back on the y-axis. No significance to that except that's just where we landed. So now we've taken care of the right one, the up one, and the horizontal flip. So all we have to account for is the vertical flip and stretch. So remember, since this is our intercept point from the x-axis, we know that in essence what's also happened is by moving to the right one, we have moved the horizontal asymptote to the right one. So now that this is upside down, instead of going down, it's going to go up the the vertical asymptote, and then it's going to come, and you don't really need to worry about the stretch of 3 there, but when we come up, or we're really down here, but what would normally be up and out, we're going to just go out further, where we could go back to the left 10 and up 1. Now we would go down 3 from there. So again, that will put us off screen, but that's going to make this curve sweep out, and it has nothing to do with that point we marked on the axis. It just happened to hit it, and it's going to be something like that. So the fact that it's 3 would make it stretch more, and you could get a bit better stretch accurately if you would have room to put that 10. So that's how we account for that, and that's the final graph and the end of this video.